Thank you so much, everybody, for joining us here today. I have here Michael Warren, who's going to be talking about JVM to .NET, the career move. Really excited to have him here and for this chat. Please feel free to post your questions on the Slido window or in the Slack channel for Room 1. Thank you so much for being here, and over to you, Michael.
Yes, thank you everyone for coming. As mentioned, this talk is called JVM to .NET, the career move. So this is about a transition I made about a year and a half ago, a year and 3/4 ago, when I accepted a new position at a company called Motorola Solutions, where I'm now a principal software engineer. When I switched, the last place I worked at was a Java shop only. And when I made the switch to Motorola Solutions, their primary stack that they work in is .NET. But as a little disclaimer, I still do Java on a regular basis. I actively now work in C#, Java, and JavaScript on the server side with Node. So just kind of help set up some expectations of kind of some high level things of what we'll be talking about here as far as our comparison between .NET and the JVM. I'm going to tell you some expectations I want to set with you guys, and then we'll dive into the differences between Java and C#, and then we'll talk about some of the tools like package managers that are used commonly around Java and some of the terminals that are commonly used, maybe with both, but in my experience, I've had one with the other. So what's some of the expectations I want to set? I'm not here to tell you that Java is better than C# or C# is better than Java. Maybe some of my opinions on some of the language features may come out throughout this presentation, but this is by no means a railing on that Java is terrible or C# is, blah blah blah. It's really just a comparison of what these are. I'm going to try to talk a little bit about those tools again, about what's around those languages, and it's not going to be exhaustive. There's so much to look at that are similar and different between Java and C#, and really the things I'm going to focus on are many of the things that are different between those two languages. So this first one was something that came up really quick in my experience with C# as I was transitioning there. There's a lot of, if you look at this difference between a map and a dictionary, Java calls this data structure a map, C# calls it a dictionary. They essentially serve the same things. As you can see here, there's a few little differences you can tell between these two different code styles. Like in C#, you can use this initializer here to set up some of your properties in advance. Kind of looks really nice and concise. While Java, you say put. In C# you have a .add method. C# also loves syntactic sugar. So you can see here with a dictionary, you can use the square brackets for your key, and then you can set the value there. Now, there are some differences in how some of these behaviors work. When I first went to C# and started working on it, I was writing my test, and I said, oh, in Java, if I say .get and the key doesn't exist in my map, then it returns null. Okay, so I'll just kind of work that way with C#. So when I got my first exception dealing this, I just blindly thought, oh, I probably didn't handle null properly. So I learned about a new little cool way of doing this. Now in Java, if you want to not get null, you want to have a default value, you would just use the get or default here. In C#, you can use this no coalesce operator, question mark, and if the value is null, then you'll get default. Unfortunately, what I experienced was that I still got this exception. So I finally slowed down, said, okay, I must be making a dumb assumption here. And I read the exception, and I was like, that's not a null pointer exception. It says the given key was not present in the dictionary. So this was one of those little things that while you're maybe expecting C# and Java to to behave similarly. This is one of those little differences that can occur between what you're doing and how you're doing. The next thing I learned as I submitted that piece of code to code review for a team member to look at, they're like, oh, you're missing something. There's something that you're totally missing because you don't know, you haven't learned this yet in C#. And I was like, okay, well, what is it? Well, in C#, there's this pattern that's called try the operation. In C#, they have this keyword called out. And it's essentially passing in a value by reference. If you remember what that is, they have it in C++ as well. The other cool thing though about out is that you can actually initialize the variable too. So if you look here in this example here, you see that we're saying out, the type is string, and the name of the variable is value2. And so if there is a value that's going to be for value2, try get value is going to return a Boolean true. And if there is no value, it will return a Boolean false. And so then in an if statement, you can just say, well, if I didn't get a value, then I can specify my default value in that if statement there. And this pattern, as I'm going to show you in a bit, actually has some interesting changes in how you can code. It's also considered in C# to more efficient to do it this way. In Java, normally what you would do if you weren't going to use the getter default, and you're going to do something else like, well, throw an exception or something that your value wasn't there because you need a value. In Java, you would do like a dot contains check for that key. But in C# you use this try get value in your dictionary. So this pattern though extends more than just the dictionary. So in Java, if you're parsing an integer or you're parsing something, it's pretty common you'll say integer.parse this string, right? Or parse int, you pass in your string, and you're going to get an exception. It's going to throw an exception, and you're going to have to handle that exception. You can't just say, well, try it, and then do something if it fails or succeeds. In C#, what you get with this try parse logic is a little bit more efficient way of handling those kind of invalid inputs. Instead of getting an exception from your code, you can say, well, I want to maybe do some custom handling of that input before maybe I return some input, some information back to the user of my function or something like that. So you kind of get this little bit of a power ability here in C# that's not necessarily available in Java. Now, fun little difference that I learned also is in Java, you can have this multi-catch. This is available, I believe it was made available in Java 8, and you can catch multiple exceptions and handle them all the same way. In C#, it's not readily available or easy to do something like that. What you see here in this example of C# is that you can catch accept this one exception or catch accept the same exception, then you kind of want to find a way to handle that commonly. Now, C# does have something else that you can utilize to try to do a little bit more multi-catching. If you want, you could do this. So in C#, if you're doing a little bit of extra logic inside your catch statement, like if you're in this example, I got an HTTP exception. If it's a 400, I want to do one thing. If maybe it's a 500 type exception, it may be something I want to retry or something like that. In C#, you can use a when clause to do that. So you kind of get rid of this nested if statement inside your catch, kind of helps clean up. You could use this when clause to maybe catch a more generic exception version and use an instance of check there. But it's just kind of a differences in how these two different languages treat exceptions. The other thing that that I didn't put here is in Java on a method, you will specify that this exception throws these specific exceptions that you need to look out for or try to catch. In C#, they don't do that. Everything's basically like an instance of a Java runtime exception, to kind of give an example of that as well. Another difference between how exceptions work here in between C# and Java is how things are rethrown. And this one caught me off guard. I was putting some code, I threw in this way, it passed through the code review, and I was troubleshooting this code in some logs, looking at the logs and trying to figure out why, wait, what's going on? Where did this happen? What's going on? This doesn't look like something that'd be thrown by this code here. And in Java, when you rethrow, you just say rethrow, and you can just say throw in the exception, and it's just going to rethrow that exception. It's not going to add anything to your exception. In C# though, what it does, if you were to write that same thing in C#, which you can, it's going to completely wipe out your stack trace and start your new stack trace where that throw is. So you'll lose all context of where that exception may have occurred. And if you so you'll still get the message, but you'll wipe out your whole entire stack trace. So if there was something that was a couple layers down and your code that threw the exception before you got to this point, then you're going to lose that context right away. So in C#, it's important to remember that if you want to rethrow your exception, you just say throw semicolon. And that's just going to protect your stack trace. You'll get the same stack trace and stuff like that. In some instances, in maybe your company's best practice or stuff, you'll wrap your exception, and if you do that in C#, it's fine. You'll maintain your stack trace. But if you want to just rethrow that same exception, you want to make sure in C# to not put that exception in right after your throws clause. You just want to say throw. The other interesting thing that I noticed, and some of this could be just kind of the convention between the different companies that I've worked at, but this is kind of what I see as kind of a standard here, is in Java, when you import something, the keywords are a little different here, import versus using in C#, but in Java, you kind of import the whole class. You say, I want to use this specific class. Now in Java, you could say my package.star, and I want everything in the package, but it's kind of looked down upon in Java. Well, in C#, you just say, give me the namespace. Which is kind of the same thing as saying com.package.star in Java, but in C#, where they call them namespaces, you're importing you kind of by default import everything. And there's benefits and downsides to both these approaches. But I found, and others who I've worked with who have been making the transition from Java to C# find that it's kind of difficult to find in C# looking at a project where a particular class you're utilizing came from in your project. IDEs do help and can figure that out by using like a control click through to get to that package. But especially if it's like a third-party package, it's like, now which third-party package that I'm using, namespace that I'm using, did this thing come from? And so it adds a little bit more work or reasoning to maybe finding what you want to do there. The other thing that I noticed before I jump into streams versus the LINQ syntaxes here is if you look at these two highlighted examples I've got here, portions here that I've got bulleted out, if you look in C#, you'll notice that double is a lowercase d, and Java, it's an uppercase D. So in C#, you can use your primitives inside for your generic values. So like you got a list of primitive doubles. And if you remember back from my dictionary example that we were looking at earlier, you notice that in C#, we were using the primitive looking like string. I don't think that's actually what it's called. I think it's a value type, is what they call that in C#. But C# does have uppercase S strings and lowercase s strings, but you typically we always use the lowercase s string in C# as well. So diving a bit more into streams and versus C#'s LINQ syntax here. So really here, in my opinion, the differences are just kind of semantics, really. The names are different. So for instance, here to start up a stream in Java, you say .stream, and then you can start doing your stream operators. So you got, filter is the same as where in C#, map is the same as select in C#, and they're just different names. I kind of prefer map over select, but I kind of like where over filter, because whenever I see anything using filter, and this could just be a me problem, I think, wait, is that filtering it to keep it or filtering to remove it out? And in this instance, it's, if you look at this, in this example here, right, we're trying to keep everything that's greater than 9 or greater than or equal to 9, right? So the where kind of makes it a little more readable, in my opinion, of I want to keep everything greater than 9 instead of filter for everything that is greater than or equal to 9. These examples are going to generate the same output. The other thing here is Java streams have terminal operations, for better or for worse. So in this case here, I have this for each. I want to print everything out, and then the whole stream will be done and over. You can't get that value out after a terminal operator, right? In C#, you basically just have to enumerate over it if you want to do the same kind of a thing. So I just kind of built it in here into this for each loop here. So we got the list .where .select, and then we iterate over that and print it out. Another difference you can see here is just kind of, again, it's just a naming thing. To print something out with a new line at the end, in Java it's system.out print line, and in C# it's console.writeLine. Just again, just a little bit of naming differences here, but sometimes thinking about what you do in one language and trying to figure out how to do another language can help you transition from one language to another. That was one of the things I really found that helped me in my transition from Java to C#, was just thinking, how do I do this in Java? How would I do the same thing in C#? Another thing here is, if you want to get a list or another kind of collection out in Java, you just say, instead of us using that terminal operator we were using with the for each, you can also just say, hey, collectors.toList. In C#, it's a little more obvious by looking at the API of LINQ of how to get that. You just say toList instead of having to figure out how to do a collectors or anything like that. This is really nitpicky difference, but it catches me up all the time. Have spent maybe a week or two writing Java code, and then I'll go switching over to writing some C#, and I'll start writing, or maybe I was writing, for a couple of weeks in C#, and I'm going back to Java, and I want to write a Lambda expression, and it's silly, but like, Java is just that single dash. In C# it's double, it's the equals sign there. It catches me up all the time. It's just one of those little differences that are usually pretty quick and easy to catch in your IDE when it says you got some uncompilable code here, something weird's going on. But it's just something I always run into. I'm also a big proponent, when you're writing these kind of streams or LINQ statements and using, in Java, they call them method references. In C# they call them delegates. And I'm a big proponent of using those because you can get some abstraction or take away some of the complex. So like if we see here in our where clause, it's very simple. But then here we're using our select statement. In Java, we're using a method reference, which is just, the class : the name of the function, right? Square root, right? And so you can take that logic, and instead of trying to inline it, I'm a big fan of pulling that out into some sort of method, right? In C#, it's just, you just put the reference to the method, right? It's math.square root. And you just don't call the method, right? You just get rid of the parentheses, and it just looks like almost like you're referring to like a property in the class. And then if you're referring to this class, so that the last example was about static methods. This one here is just to show you if you're referring to a specific method on this instance of the class, it's this : my function. While in C# you say my function. So there's a little difference there again, and just on the syntax. It's not that big of a difference between the two different languages, just the way I have to do the same thing in both languages there. The other thing that's a little difference here between method references and delegates is how if you want to specify what your own, you want to create your own definition for a method reference or your own definition for a delegate, right? In Java, you create a functional interface. So you have to define a whole full out interface with one function in it. And you have to, you annotate that interface with @functional interface. That kind of lets the Java compiler know that this should only have one function on it. So that kind of, so that's what that annotation there does. And then you can just refer to it in your class. In C#, you can just put a delegate anywhere in any your namespace, or you can define it in your class if you want to. But the gist of defining a delegate definition in C# is to just say, whatever the visibility is here, public delegate double my function, right? And you have the definition. You just specify, you just give that delegate keyword there, and that takes care of saying that this is really just saying this is some sort of type that I can pass in now. And then of course you can refer to that, just like we did with that my interface over there. We can refer to that my func in my class here. So some tips there of how to do the same thing in the same place. Now, what we've seen so far is some things that are similar, maybe slightly different between the two languages, but they've been very much the same. We're now going to talk about is asynchronous code. And I will admit, I don't have a lot of experience doing this in Java. So if there's a better way of doing it, feel free to let me know. And you can see, you can see what those differences are. You can let me know if there's a better way to do it in Java. But there's a big difference, in my opinion, between how Java does asynchronous code and C# does asynchronous code. So what you see here in Java, in the Java world, in Java 8, they introduced completable futures. And in completable futures, you say completable future dot supply async, and you pass in your lambda. You could pass in if you have a method reference that meets the callable interface, you could do that too. And you don't have to call completable dot is done here. You can just skip that part and just call the .get. But .get is a blocking operator, right? So if you're trying to wait for some other things to happen or stuff like that, you can grab that future and then access it when you need it at the same time. And C# it's a lot more succinct, in my opinion. It's more clear. If you're familiar with JavaScript, it's basically the same kind of thing that JavaScript is doing there too. In JavaScript, so in C#, what you just do is you annotate, you can say, okay, this method is an asynchronous method, and then you can start awaiting other asynchronous methods inside of your method. So in this instance here, we got long result, right? And we can await factorial. And then when we finally use that instance, that's when it will finally maybe block. But until then, until you actually use that return value, it's going to allow for other things to flow. The other difference between these, how these two languages function with asynchronous code, is Java spinning up a new thread in the background. So when you're saying completable future dot supply async in Java, you're spinning up a new thread in the background to operate on that. While in C# it's trying to keep things on kind of on the same thread. It's keeping things on the same thread. If something blocks, it'll push it off and start operating some other things, and then come back to that operation to see if it's completed or not. So a little bit of differences between how those two things work. I've got a comment here in Slack, someone saying that you can say toList.forEach. That's true. but you that is another way of doing it, but you have to convert it to a list. So we're going back real quick to that comment. He's talking about this example I have here. Yeah, you can definitely to-list it, but if you want to, it's not directly available off of the IEnumerable. So if you had a list, it will when you say .where .select, it will transform that to an IEnumerable instead of a list. So we have to convert it back to a list before. So you'd have to say to-list here, and then you can say .for each. I probably should have mentioned that. Thank you, Neil. So do we have any questions on Slido?
Not any so far.
No,
so,
no, okay. Yeah. I do want to encourage you guys, if you have any questions, to post them so that at the end of the presentation, I can answer those. When we get to the end of the presentation, there's a lag. And so when I do ask for questions at the end, you probably won't hear me say that until 30 seconds after I've actually said that. So I'm going to just get back in here. So the next thing that I discovered, one of the other things I discovered as I was writing tests, there was this thing about access modifiers and other and how to override functions in C# and Java that were very different. So just kind of give you an example. The frameworks I'm using here in C# that I'm referring to is XUnit. That's what I use. I'm not going to get into an argument about what's better between NUnit and XUnit and C#. Java, I'm using JUnit. There may be some, I think the syntax for what I'm using here is the same between JUnit 4 and 5. So there's not really that big of a difference between those different languages there, those different frameworks for those testing. But what you see here is it's a kind of a really small difference here, and we'll kind of dive deep into why this is, and then we'll talk more about maybe some of those ramifications on your code base between these two differences. When you're writing Java tests in Java, and the mocking framework I use is Mockito, and when you're writing tests in Java, you can just say, well, I'm going to mock this class that I have, and then that's my dependency, and then I will pass that in, right? Well, in C#, your public methods are by default not overridable. You can't. So when I was writing my first time writing my test, I wrote it just like I would write similarly as I would write it in Java, and I tried to mock a concrete class, and it didn't work. I got an exception saying that the method that I was trying to mock the behavior of was not virtual. So that kind of brings us here where, just to kind of highlight this difference, this first example here at the top is exactly the same, right? But if you notice in C#, you have to specify this virtual access modifier. And this is the only way this is the typical normal way to indicate that your method is allowed to be overridden by your children class. Typically, they're just visible, but public is visible by those things, but they're not overridable. To kind of drive this home a little bit more, right? If you look here in this example I have here, the C#, the first class I have here called helper, the first method I have here in this class called helper is protected. But you can't override that in a child class. You have to specify the virtual keyword in order to be able to specify that keyword to be able to override that by default there. The other thing in Java is Java has this ability to not specify a modifier. This means that something is not visible outside of the package. So if I were to inherit prime service with a child class, complex, hard to reach is not available to be visible would not be visible in my child class, unless the class that's inheriting prime service is inside of the same package as prime service. This, I don't use this visibility a lot in Java. The thing that I normally use it for is if I am dealing with some legacy code and I have a function that's in a Java class that I want to test that's currently private, and I need to get access to that, and it's kind of a hard to reach thing that's from the public method, then I'll drop that modifier and use that in maybe a test or something like that. C# doesn't really have the same kind of access there. In Java, you have to make sure you set up your test packages similarly. It's the same as your packages for your production code as well. But that's just a little tip that I learned in Java on how to get to those hard to reach places. I will also usually indicate that function as final as well, just to help protect it from getting overwritten by children that may exist in the same package. So this is just kind of an overview of the different access levels that are available. C# has a bunch of these other access modifiers that are available, these internal, protected, internal, private, protected. I haven't used them in my development in my development, so I'm not really well versed or familiar with those, and I just didn't feel like taking the time to research them out, so I'll probably get called out. But if you want to figure out what those ones do, it deals something with the assembly of the package and stuff like that. So it's some differences there. You can go look. Microsoft's got some pretty good documentation on what those do. Some of the other things that I want to talk about here was some of these modifiers. So the ones I highlighted here are ones that I didn't want to pull out an example because they're very simple and straightforward. Abstract works the same in Java and C#. Final and sealed are the equivalent in C# and Java. So if you specify a class as final or sealed, you can no longer inherit from that class. You're basically, so if you're maybe creating a Java library or a C# library or C# DLL, if you don't want someone to inherit from a class of yours, then you just mark it as sealed in C#. In Java, what you would do is mark it as final. Same goes for different methods, right? You just mark them as final or sealed if you don't want someone to inherit from that or change the behavior of that function. So one of my favorite things, and I didn't actually learn until I presented this presentation to my teammates, one of my favorite things that I used in Java was the synchronized, not favorite things, but it was one of the things that when I needed it, it was really nice to have in Java, was the synchronize keyword. What this allows for is if you're in a multi-threaded environment, it allows you to easily specify if a thread can go into this method or not. It allows you to lock it. So if you're used to parallel programming and you use mutexes or semaphores or stuff like that, right? You can kind of get rid of a lot of that cruft and the excess there, and use the synchronize on a method or synchronize on what's like your field, right? And in C#, the same way of doing this for a method is using this annotation. And we saw an earlier example of a Java annotation, and the difference between how these annotations are specified is kind of Java's got the @ sign, while C# puts them in square brackets above the method that you're using there. But these two code examples here are essentially identical to each other, right? They're gonna get you the same results, right? You're not gonna have more than one thread operating in this method. So if you got some sort of like counter or something that you've got going on that's going to be updated by multiple threads, or some other example that you have, these kind of things allow you to protect those areas from getting into a weird state. So now I want to come back to probably to my discussion that I was talking about earlier, right? Now in this example here, I'm showing you the differences between interfaces. They're almost actually, I think they're exactly identical. But the thing I wanted to point out here is that the way with how I was talking about with access modifiers in C#, you see this convention where you will have a interface that's identified as an interface in C# with I and then the thing. And what I see a lot in C# is that you'll have the interface I the thing, and then you'll have a class with the exact same name called whatever the thing is. So in this case, we may have a prime strategy, and then you'll have a class that's called, so we've got the interface I prime strategy, and then you'll have a class called prime strategy. In Java, because of the way you're doing your testing, even though you're doing the same kind of stuff in your testing, Java kind of allows you to be a little lazy, for better or for worse, and you can mock those things and not create your interface up front. In both instances, it's important to follow the single responsibility principle, the interface segregation principles from Solid, to keep your interfaces and your classes concise. But what I find in Java is, if I have my class prime strategy, that because I only have one prime strategy in my whole whole application at the time, then I only call it prime strategy. But if I have if I do need the time to have two different prime strategies, I don't have this what I call fluffy interface that just has this I in front of it. When I need to, then I can say, okay, what's really the role of this interface, and I can call it by what it's really called, instead of using this the convention in C# where it's always putting this I in front of it. So this next one comes from experience I had. I had spent most of my time in one project of ours, and I had found this really cool method on our when I was using LINQ, using some LINQ stuff, and it was this really cool where function that we always used everywhere, so I didn't have to write it over and over and over again. And then I went to start working in another code base of ours, another project of ours. And I was doing the same exact thing that I've done in the other project. And I'm like, wait, where is my really cool function? Where'd it go? I can't find it everywhere. And I double checked that I was using the same version of C# because, well, maybe it was in, an older, maybe this one's got an older version of C# or something like that. And I just couldn't find it. So I turned to one of my teammates, because I spent enough time trying to figure it out myself. And they said, oh yeah, that's because it's this C# extensions method. This is a concept that doesn't really exist in Java. The closest you can get in Java is you have static methods, right? But they don't suddenly become part of the interface of a class or another interface. They are, in Java, that's always just, you have to go grab your static thing. It's usually pretty clear that you're grabbing something from somewhere else. But in C#, you can extend the behavior of a existing class, even if it's sealed, by using an extension method. It takes in this, and you have to deal with whatever is publicly available, right? It's not an actual inheritance of it. But then you can do whatever things you want to do in your really cool, where function clause. This one here is, of course, a bogus, really cool function. All it does is return true for your for what it does. But it allows, these extension methods allow for you to extend without modifying a existing class or something like that, if you have something you do a lot in your code base. So it's just one of those really shocking things that blew my mind in C#, where you could do this thing. And we at my company use these a lot, especially when we have a library that we want to make it easy for someone to not do the wrong thing when trying to hook it up to their dependency injection framework. So now we're exiting out of talking about the differences between C# and .NET, and now we're talking about some of the tooling around them that are commonly used. In Java, where I worked last, we used Maven, and my understanding still is that Maven's one of the big hitters on there. But the other one that's up and coming, or just as big as Maven now, is Gradle. Those are your two main package management systems. I'm sure most of you are familiar with one or the other of those. There's some other ones that came before Maven and Gradle. Maven and Gradle have their advantages and disadvantages to use, but I just want to kind of hit on some of the high levels between these package management systems instead of diving too deep between them. Partially because I don't have a lot of in-depth knowledge and experience with them. I kind of use them to manage my dependencies, and that's about it. But some of the things I wanted to mention here is, so with Maven and Gradle, both of them, you can exclude a transitive dependency if you need. So if you're having some sort of conflict, you can say, well, get rid of the one the older one, use the newer one, or vice versa, if that's okay or something like that. That's one of the main uses that I've had of those. In Maven's when you have your Maven file, it's XML, right? And in Gradle, it's actually a Groovy configuration. It's Groovy code. If you can do it in Groovy, you probably can do it in your Groovy configuration. So the other thing that I found about Maven and Gradle, and someone can correct me wrong, that's different between NuGet as well, is that you can create plugins for them. So if you want to extend some stuff in your build configuration or your build you want to do, one of the examples from the last company I worked at is we had a database of different either invalid combinations of libraries or libraries that we should no longer use. Or if we discovered a library that we published internally had a security vulnerability, want to get everyone off of it as quick as possible, we would put that into this repository, this database as a banned dependency. And then when you built it, since everyone was supposed to inherit from the same Maven configuration before they built out theirs, you would get a warning or a build failure about these banned dependencies or banned dependency combinations. And that's something you could probably do with Gradle too, because you can create plugins for Gradle as well. My experience, I haven't seen it, and maybe someone will correct me if I'm wrong. With NuGet, you can't exclude transitive dependencies, and you can't create plugins. I haven't seen anything. I'm also sure that I saw there's a couple other package management systems. I haven't used them, so I can't say anything about them. NuGet's kind of the big one that I hear. NuGet's kind of similar to Maven in that they both use XML to define things, although I do think that the NuGet XML is a little cleaner than Maven. And I apologize that I didn't put an example of those configurations here in my slides. Partially because my next favorite thing to talk about is terminals. I like automating my tasks. All those package management tools, you can use them from the terminal. I really enjoy automating my simple tasks, my complex tasks, so I don't have to do the same thing over and over again if I don't need to. So the first thing I'm sharing here, the differences in how to do the same thing, is really kind of the story here with terminals, is grep. Now, bash I learned in college, and I used bash or shell I used in college. I used it a lot. When I went to start working in my last company, that's what they used. So I used a lot of bash and shell. To me, they're kind of the same. I know that there are some differences between the bash and the shell, but that's what it is. That it is what it is. But you use grep, and it took me the longest time. I don't know why it took me so long to figure out how to do grep in PowerShell. I just couldn't figure out what the real PowerShell command was for grep. And then one day I stumbled upon it and found out that you can do select string. I did determine that there was I did notice pretty quickly there's a difference between the behaviors of these, where and what you're seeing here in the slides is the default behavior, where when you grep dog from a file, it's just going to show you the line. If you want to get other information, you got to add some additional options to it. And in PowerShell, the difference there is it gives you the file name and the line number, and it even highlights the match where it is. So if you're using like a regular expression match, it'll highlight where it matched, and you can figure out, well, why did that line show up? Didn't expect that. Oh, and now I see that's what matched, and I can go to in my regex or whatever for that. The other difference here, we all have seen this this joke, just giving someone this command on the bash, telling them to run it, and I lost all my files. Well, it's probably a little harder to trick someone with a PowerShell script because it literally tells you what it's going to do. You're going to remove the item, it's going to do it recursively, and it's going to force it. Meaning you're not going to have an opportunity to say, do you really want to delete this? If you can, it will. These two deletes everything. You can take from there on how to do it. It's just kind of some of the differences between these two languages. PowerShell, you'll see over and over again, is a bit more verbose, but typically more clear of what it's going to do. And Bash, if you want to print out the contents of a file, you say cat, the name of the file, and to print out that contents of the file, you say get contents with the file name. Something that I also want to point out on this slide that you probably saw on the other slides too, is that in PowerShell, you've got this dot backslash going on before all your file names in PowerShell. It's just kind of how it does it. When you do autocomplete, it fills that in for you. Both terminals also have the ls command. I believe in PowerShell, this is actually an alias. I'm too lazy to figure out what the real name of ls is because it works just fine for me. But if you want to list contents in your directory, you can do ls. And in both of them, in PowerShell, it's going to give you the same thing as ls-a. No, ls-l, sorry, ls-l, that's you. If you did ls-l in bash, you get the same similar content output as you get with the PowerShell command. PowerShell just does that by default. Yeah. The other thing here is how to make web requests. Now I know there's other ways to do this curl command in bash or shell. I just kind of was being real quick and copied it from Postman, because Postman will allow you to get an example here. And so to do the same kind of get a response from a web page in curl PowerShell. So PowerShell for get, you could by default also say curl, that's aliased. A lot of these commands that you see in the bash, they've aliased in PowerShell as well. I think someone's mentioning that on the Slack page. So what you see here for curl is, right, you just kind of give these parameters. For invoke REST method, you just kind of specify the URL and you can say the method as well. There's other ways to write these commands too. I think some of the stuff is kind of optional, right? If you're doing a GET request, and both of them, I don't think you need to say the -- location in curl or the -- request or GET. You can just say curl the URL, but there's some additional things if you want to get to a post or stuff like that. And there's obviously different ways. Now, one of my favorite ways of getting requests though, when I'm doing an automation script, and this kind of highlights a big difference between the bash PowerShell, between bash and PowerShell, is how easy it is to kind of create like an object thing. So I prefer instead of using a REST method, I prefer to use web request because it gives me all the details of my my response. So if it failed for some reason, I can get some additional information, like was it a 500 or stuff. And you can do that with curl too, but the big difference between kind of the two of them is that you'll get an object, right? So if you're trying to create a script to automate things in PowerShell, by default, it kind of makes it much easier and nicer to do that, to write that automation there for yourself instead. I just wanted to add this slide of, okay, now what? Now that I've told you some of the differences, now what? I just want to kind of re-harp back onto if you're scared of learning a new language, you're in a place with your current company that you're just ready to move on to a new company, but you're afraid of interviewing with a company that does different languages than you do. You know, the best thing to do is to just to think, how would I do this in my current language? And then go and Google it. How would you do this in C#? Or how would I do this in Go or Python or JavaScript? And you'll get a lot out of that. So, you know, don't be afraid. Don't be afraid to apply for a company or listen to a recruiter from a company. If you're ready to move and you like you like a different company, but you're scared about the different tech stack they have, don't be afraid. You'll learn it. It's the smallest difference in your ability to ramp up at a company is learning the language or learning a new framework. You'll be able to learn it, is my opinion. A language is a language. There's different tools that you have available to you, really. And once you learn more, it really just helps you be a little bit more marketable, in my opinion. So don't be afraid. Just kind of forge out there. You know, when I was looking at companies and I looked at Motorola Solutions, I forgot to mention this before, not to be confused with Motorola Mobility, which is a cell phone company. Motorola Solutions is a company that deals with public safety and first responders, school safety, and stuff like that. And I was like, oh, that's actually really cool. And having had learned Clojure right near the end of my time at my last company that I worked at, I took the courage knowing that I could figure out how to learn a new language, figure out how to learn C#. And I also had some background knowing that there's some similarities between them that I figured I'll just jump in and join them. Do we have any questions?
So I think there's been a lot of discussion on the Slack channel, but I don't see a specific question as such. Just discussions about the for each methods. I think you've also been reading some of those, but the latest one is from Phil, which talks about ls is an alias for the get child item.
Yep. Thank you, Phil. Neil, that's a really good point that you brought up. You don't need to do C# to use PowerShell. You're right. I forgot to mention that. Presenting, kind of forget everything you're going to say.
So, and there's some discussion about extension methods, but how the discoverability of those is really hard. But yeah, if there are any specific questions that you'd like to be answered, feel free to put them on the chat window. We'll keep it open for a few more minutes because given there's a slight lag, I want to make sure that we get all of those answers.
Okay. Is there any questions in Slido? You said no questions in Slido?
No, nothing on Slido. Cool. I think Phil had posted on Slido and then he posted it again here.
Cool.
In Slack as well. So.
Yeah. All right. Thank you everyone for coming. Please leave me feedback. This was my first time presenting at a public conference. The last time I presented to anyone was probably about 1.5 years ago at my last company internally. So please, I've created some QR codes you can use your phones with, or I've put the feedbacks back down at the below. If you want to get access to the slides, I created a QR code so you can get view access to the slides as well. But thank you everyone for coming.
Well, I think we have one question.
Oh, we do?
What has been your favorite thing moving over, and what was the thing you missed the most? And this was from Neil.
Neil. My favorite thing about Java, in all honesty, comes back to one of the things I miss the most is really this ability. I'm going to kind of skip back to this slide. Is the ability to mock a concrete class and its public methods. Maybe that's just because I'm a naughty developer, but I love the that kind of laziness there. One of the things, there's actually a lot to love about C#, but probably one of my favorites is the ability to, the no coalesce operations are real fun. I haven't actually dealt a lot with extension methods. My feelings are still mixed on those, but I have to say maybe the no coalesce operator is one of my favorite things about C#. Also, a lot of the syntactic sugar. I like my sugar, I have to say. So those are kind of that's my answers, I guess, to that question. Yeah, my favorite thing, the thing I miss about Java is being able to mock those concrete classes. And the thing I like about C# most is the no coalesce operators or other syntactic sugar things.
Okay.
So.
I think I don't see any other specific questions.
All right. Cool. Everyone, list your favorite language to hate on down at the bottom. In the Slack, list your favorite language to hate on. Let's do that. I bet we'll see a lot of Java. All right. Thank you, everyone. Have a good day.